This is a little mini lesson in Unit 12 in regards to z-scores. This is something you learned in Algebra 1, but I'm noticing that a lot of people have forgotten, so we are going to go ahead and just do a quick little recap over it. Excuse me. Okay, so z-scores. Z-scores essentially are your standard deviation. It's how far a value is from the average, from the mean. It kind of gives you an idea of a location. So the importance and the point of a z-score is to compare things that aren't comparable. So you've always heard that phrase, you can't compare apples and oranges. Well, using z-scores, we actually can do that. We can compare them. So let's first take a look at what our z-score is. So here's the formula. Once again, nothing you have to memorize, it's provided for you. But the z-score equals x, which is the given data, okay, meaning the data value. So if we're talking about like SAT scores, your score would go here, minus the average, okay, mu stands for average, divided just by the standard deviation of the data, okay? So let's take a look at some examples. All right, so it tells us the heights of 16-year-old males are normally distributed with mean of 16 or 68 inches, standard deviation of 2. So find the z-score. So if I'm asked to find the z-score, I'm just literally plugging the values into my formula here. So I have z equals, x is your height, so in this first example, is 70 inches, minus the average of 68, with a standard deviation of 2. And then I just type in my calculator, I do math, and I get a z-score of 1. Okay, now 66 inches. So I'm doing z equals 66 minus the average of 68 divided by 2. So I get negative 2 over 2, which is negative 1. All right, so I have two different options. So let's kind of figure out about the sign, because one number is positive, one's negative. So what's the significance of the sign? All right, it tells you which side of the mean that you are located on. So for example, if you look at this, the average is 68 inches. This first person, he's taller than average, correct? Because he's 70 inches tall. That's higher, bigger than average. His z-score was a positive. The second person is only 66 inches, so they are shorter than average, and their z-score was a negative. So the significance is it tells you how you compare to the average. If you have a positive z-score, you are above average. A negative z-score means you are below average, okay? And that's just what it tells us right there. All right, so let's go ahead and just calculate some. Let's just do one or two here. You're more than welcome to pause and do more on your own. But first of all, let's predict if they're going to be above average or below. So same thing, our mean is 68. So 71 is above average, so that should be a positive z-score. 74 is above average, so that should be a positive z-score. 64 is below average, so that should be negative. 62 is below average, so that should be negative. 68 is average. So what do you think our z-score is going to be in that case? Well, let's figure this one out. So my z-score is my data value, which is 68 minus the average, divided by 2. So I end up with 0 divided by 2, which is 0. So if you have a z-score of 0, that tells you that you are smack dab on average. So this person's 68 inches. Or if you know that your data value is the same as the average, your z-score will be 0. All right, so will the mean of every normal distribution have a z-score of 0? Yes, because that is one of the characteristics of z-scores. Or I'm sorry, even normal curves. The average is 0 and the standard deviation is 1 always. Okay, so just now, how can we use them to compare? Sorry, I'll move this out of the way. So it says we've discovered the data below, blah, blah, blah. So the mean will always have, wait, hopefully you've discovered that data below the mean will always have negative z-scores, sorry. And data above the mean will always have positive z-scores, okay? And the mean itself will always have a z-score of 0, always. So suppose the test scores on the last exam are normally distributed, the z-scores, blah, 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 blah. Which ones are below? And color coding also helps, but it's the ones that are negatives. These ones are below. Which ones are above? The ones right here that are positives. And then, if the average score was an 80, did anybody score exactly an 80? Yes, whoever got the z-score of 0. So remember, z-score is just telling you your location to the average. Positive means you're above, negative means you're below, 0 means you're smack dab on. And then, of course, we can compare between there. These two people are both positives, but this person, whoever has this z-score, did better. And we can calculate what their actual score is knowing all the information, which we're actually going to do down here. But they're both above average, but this guy did better because his z-score is further above average. It's farther away from the mean. Okay, so which z-score represents the student who scored the highest? This one right here. So let's actually calculate his score now. Okay, so it tells us in this example the average was 80 and the standard deviation is 5. So this time we have Z, we're solving for X. Okay, right? So Z-score is 1.95. We're trying to find what the actual score on the test was. So, oops, that should not be there. That should be an 80. So solve for X. So multiply out your denominator. So we've got 5 times 1.95, which is just shy of 10. 9 and 3/4 equals X minus 80. So then we're going to add 80 to both sides. So the person who scored the highest got a score of 89.75, which, yes, the computer would round up to 90. Okay. All right. So that is all. So let's really quickly talk about a comparing one. So let's say, here we go. How are we going to compare using Z-scores? So on the SATs, let's say you took the SATs. The average score for the SATs was an 1120, and you scored a 1200. Okay. And then your friend took the ACTs, in which the average score was a 28, and they scored a 30. Now, we want to see who did better. We can know that both of them scored above average, so that they should both have a positive Z-score, but we want to see who did better. Oh, we need standard deviation too. I'm just making stuff up. I don't know, 120 standard deviation, and this standard deviation is 2.5. Okay. So all we can do for both is calculate the Z-score and see who is higher. That will tell you who did better compared to their data, and I'll explain that in 1 second. So for the SAT person, we'll call them John, put a J, and ACT is Lewis with an L. So John's Z-score, we do Z equals the data value. He got a 1200 minus the average is 1120 divided by, I said the standard deviation was 120. So we know it's going to be positive because he scored above average. So you at least know that. So type it in. Divided by 120. So his Z-score was 0.6666. Okay. All right, now Lewis's Z-score. Let's see. Lewis got his data, he got a 30, and the average is 28, and standard deviation was 2.5. So we have 2 divided by 2.5. So his Z-score is 0.8. So that means Lewis did better. Okay. Now, once again, we both see that they scored above average because their values are higher, but you have to take everything else into account. So it's saying that when you compare Lewis's score to the average and all the other students that took the ACTs, he scored higher than John did. Okay. So this is how we're comparing apples to oranges. Otherwise, we can't really compare ACTs and SATs. That is all.